So now let's start it up again with part C. And in part C, they're actually telling you what to do to create this summation formula, to see this series formula. And so we're going to add our terms vertically from what we had in part B, and then use that to reach that conclusion and that proof that they're asking us to show. Okay, so when we start this off, we're going to think of this as basically 5, 2, 3, 4, and 5. My equal sign, of course, just comes straight on down. I'm going to add up whatever I have on my left side, and then do the same thing with summation, with adding up in each of these columns, if you will, each of these way down. Is that with this first set of values, they're going to happen over the course of n times. Okay, it's over the course of n times. So when we're looking at how many times connect it with n, and that's going to be important when we're determining how to write our series out. So left-hand side, just go ahead and let's simplify these so we can see what's happening here numerically. So 0 plus 1 cubed is just the same as 1 cubed. 1 plus 1 is 2 cubed. 2 plus 1, 3 cubed. And it goes right on down the line. So 3 plus 1, 4 cubed. It happens all the way down cubed, which is kind of just before we get to this one, of n plus 1 cubed. So if we're adding vertically, we're adding all these values. I've got 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed all the way down to n cubed, and then n plus 1 cubed, and that's where I'm ending. All of these guys, so I can say, all right, well, that looks like a series where I'm starting with a value of 1, and I'm going to n, and it's going to be whatever that value is cubed. Okay, it is cubed. So I'm going to write that as k cubed. Now this n plus 1 cubed, that's going to sit out on its own because it's not a part of what we've described in that series set. It's everything up to that n plus 1 cubed, which is totally fine. Works out beautifully. And let's look at our next column. So right here are cubes. So we had 0 cubed, 1 cubed, 2 cubed, 3 cubed, n cubed. What's nice about this one is that it ends with n cubed, so I don't have to worry about doing anything additional or special. And with 0 cubed, that's basically just 0, right? So if we were to think about it series-wise, it's like I started with 1, went all the way to n, and every time I was cubing whatever that value was. Okay, because again, this is addition, we're adding vertically. So this creates its own little series. And we're saying, okay, well, let's start with 1, because this one doesn't really count. I mean, it does, but you understand what I mean. All the way to n, and that's going to be cubed, that term cubed. Cool. Then let's see the next thing that's happening here with our squared terms. It's 3 times 0 squared. Again, this is basically 0. But then I have 1 squared, 2 squared, 3 squared, all the way down. I'm saying I'm going to do 3, whatever this summation is, squared, because I'm adding them up. Squared, 3 squared, all the way down. So I'm going to put 3 summation going from 1 to n, because I'm thinking about this from 1 to n, and I'm ending with that term squared. Got that k squared there. Doing something similar here with our single terms. So I'm starting with 3 times 0, which again is basically 0, but I have 1, 2, 3 all the way down to n. So I'm going to describe it in a similar way where I can write it as a series. Now the cool thing with this is that it's such a nice and lovely compact way to write these. You don't have to write it all out. You can just put it together with a sweet little sigma notation and you're good to go. Fits in your pocket. Now this last one, this term is interesting because again times, and then you get to n plus 1. Okay, so we have that 1 extra, if you will. 1 is happening n number of times. So if this was a series where we went from 1 to 3, right? If we went from 1 to 3, then we would have had it 4 times. If we said that we were going 1 to 2, we would have had it to happen 3 times. If it was to 1, we would have had it happen 2 times. So we have n number of times plus an extra 1. So it's like happened n plus 1, because it's just simply the number 1. We can make that into a summation thing, but it'd basically be saying add 1 to itself this number of times, just simply, okay? So that's how we've got that. So now let's take a look at what we have here on the docket. Notice that we have this summation of k cubed and k cubed on both sides of our equation? Yep, starting with 1, ending with n, they look exactly the same. They're functioning exactly the same, which means I can cancel them both out. Bye, guys. And now here on the left with n plus 1 cubed, 3 with a summation from 1 to n of third. And then I've got my summation from 1 to n of just k. And then I have my n plus 1. Now, to make it look exactly like what they have in our book that they want us to show, we can just go boop, boop, and we're done. So now we've created those parentheses. This is what they were looking for us to show. And that's exactly what we've done. So now we can start thinking about part D. Is that out? And they actually give us a tool to explain this term. Okay, given that the summation from 1 to n of k is equal to n times n plus with that k squared term. So what we're going to do is we're going to take these pieces we have. So they've told us what to do, or another way to describe this summation portion, and to figure out how to get just this summation portion from 1 to n k squared by itself. So let's get to work and do some substituting. Let's just go ahead and do it. So with our left-hand side as just n plus 1 cubed, we're not going to touch that right now. We have our 3 summation from 1 to n k squared. But then here, place this out. So we have 3, and then we're going to write it as that n plus 1 over 2. Right? Then we have our plus n plus 1. So that's now our rewritten form of this equation. Now, I don't know about you. It's one thing already to have summation and learning that and figuring that out, but then you're going to throw a fraction in the mix. So what do we do whenever we have an equation and there's a fraction and we'd rather not have fractions? Multiply everybody through by a common denominator. Okay, so in this case, that fraction is divided by 2. So we're going to multiply everybody through by 2. Everybody gets 2. Everybody's going to get multiplied by 2. Okay, so that means I now have 2n plus 1 equals 6. Summation from 1 to n of k squared plus, this is now going to become just simply 3n n plus 1. Yay, no more fraction. And 2n plus 1. Okay, so now let's do some rewriting. So we need to get this summation k itself, which means you guys are going to have to move to the other side. So I'm going to write 2n minus 3n n plus 1 minus 2n plus 1, and that equals to 6 times the summation from 1 to n of k squared. Let's go ahead and clean this up because that still feels like we could do some work here. It's happy polynomials. We can figure this out. We've got this. So we remember, of course, this down so you can see it. So we remember from earlier that n plus 1 cubed was this n cubed plus 3n squared plus 3n plus 1. So now we're just doubling that. So let's just go ahead and double it. So that means we're going to end up with 2n cubed plus 6n squared, 6n plus 2, so that takes care of the part of expanding it. Then we have, thanks so much, then we have this 3n n plus 1. So remember the minus there, so it's basically saying minus 3n squared and then minus 3n. So making sure to distribute that through. And then for this term, we have the 2, to subtracting 2 with the n and the plus 1, so that means we have minus 2n and then minus 2. And that is equal to 6 times our holy grail summation. This lovely polynomial on the side, because I feel like we can do some canceling out. I see some things that might be able to clean up a bit. All right, so in terms of the cubes, there's no other cubes, so that's going to come on down. Okay, with the squareds, I have a 6n squared and minus 3n squared. So 6 minus 3 gives me a positive 3. So I've got n squared there. And I like to do these so I remember what it was that I've put together and I don't miss any terms, because I could easily miss something, and this is going to keep me on track. Then for my single n term, I have 6n minus 3n minus 10, which takes me down to 1n. So just a single n. Thanks, friends. And then I have a positive 2 and a negative 2, so they're going to just go out. Okay, so I have 2n cubed plus 3n squared plus n. And now back over, and we've got 6 from 1 to n. And there's my k squared. That looks a lot. Notice something here. We can factor this a little bit more, can't we? Let's pull out an n from all three. That gives us 2n squared plus 3n plus 1. And all we're doing is we're keeping in mind that apparently we're like a set of factored terms over 6. The 6 I can already see happening because let's see what we can do to clean this guy up. So we've got the n. Now when we have 2n squared plus 3n plus 1, I can factor that. I can totally factor that. So now I'm going to have a 2n. I'm going to have an n because it's going to get me my 2n squared. I know that I should have a 1 because that's the only way I'm going to be able to and get that plus 1. So let's just go for it. Let's just do that. And let's check to make sure we're getting that n. So FOIL, F, that gets me the 2n squared. The outer, so that's my 2n. And then I have my inner, so the 2n plus the 1n gets me the 3n. Awesome. And then plus 1, good to go. So we are right on. And so there is this part written there. And so now to finish it up, we just divide everything by 6 and that by itself. So that gives us n, 2n plus 1, n plus 1 over 6. And that is equal to our series of k squared. And that is that, my friends. So the great thing with this particular part, with part D, was that again, they gave you how to do and what to expect for that squared term. So they told you up front how to do this and to do that replacement, which was super helpful. So by being able to just do that replacement automatically, that jump started this process so we could get to our happy conclusion. So hope that helped. Have a great rest of your series and sequence set, and I'll chat with you later. Bye.